So I thought I'd make a bit of a Wheelieometer construction video. This is the completed improved Wheelieometer, and then I've just started cutting a batch of 3 boxes to fit the components in, and this is really the bit that takes the time, is cutting the holes out. So this one I've already cut the hole for the battery and the display, and this one I've just done the battery, and I'm just about to show you how to do the hole for the display. So this is the battery holder, which just fits into that hole there, and then the display needs to go about here, and this is the display itself, so that will mount behind the panel. So the first thing I've got to do is to mark on the box where I need to cut the hole. So I need to allow enough clearance along the side of the battery holder. So I'm just going to mark the box along where the edge of the battery holder is, which is about there. Then I need to mark where the edges of the display are, and you can just about see where the edge of the actual display is, which is inside of the glass. Now we have this rectangle marked, I'm going to drill a hole inside of it, like that. Then I've got this rod saw blade inside a junior hacksaw frame, and this rod saw will cut in any direction, and I'm going to cut round inside that rectangle, making sure I'm inside it all the time, and it doesn't have to be particularly neat. So there we've got that hole, and then I'm going to get the file and I'm going to file it back to the line very carefully and make a nice neat opening in there. So that's that, and that's probably the neatest one I've done out of the 3, so I'm quite pleased with that. So I've also now marked where the 4 mounting holes need to be. Now with these displays you have to really do it on a mark each one individually, because the display is stuck onto the circuit board and it's not always particularly well aligned with the circuit board. So I'm doing each one individually. So you can see that this one, the display is sort of slightly offset to the side. And then also when you're measuring between holes, see the distance between the holes, it's actually easier, instead of trying to measure from the middle of the hole to the middle of the hole, it's easier to measure from the left hand side of the hole to the left hand side of the other hole, which of course is going to be the same as the distance between the centres. That's a bit of a tip there. These have now been drilled out with a 2mm drill, ready to take the display. Then I've got to do those on the other boxes. So then I won't bore you in the video, but I've got to cut all the other holes. So basically the battery and the display are now done. The switch is basically the same sort of cutout, except it's much smaller obviously. And then the USB socket's a bit of a funny shape. That'll be done with a file. And then we've got to drill all these other holes for the LEDs and various bolts and things. The only slightly strange thing is the Arduino board. There's only like a couple of holes to mount it with at one end, and the other end is held in with the USB socket. So what I was saying about the displays all being slightly different, you can see this one's stuck on quite cockeyed and it's quite firmly stuck, so I don't want to try and unstick it, so I'll just mount it at a slight angle. And now what I've done is I've marked all the back of them with the pen, like this one's got a C on it, and I've marked the box with a C inside, so I'll know which display goes with which box. So you can see here just how wonkily I've had to drill these holes to make it line up with the holes on the display, because it's at a funny angle. Another useful tool is these hand reamers for making holes of a specific size, like these buttons for example. The drill I've got is slightly too small, so all you do is open the holes out slightly with the hand reamer. It's difficult to do it one-handed though. And then that will make you a hole of whatever size you want really, because it's just slowly opening it out. So the next thing to do is all the soldering. So I've soldered the pins onto all the Arduinos and some of the components that I've got. And I've soldered the wires onto all the buttons and the connectors and the switches. I'll just give you a quick demo of some soldering now. So first we have to what we call tin the connection. So we just melt some solder onto them. And then we take the wires and we solder them on. I've also got some more circuit boards here that needs pin soldering on them. Here's the temperature and pressure sensor. So what we do here is we've got it pins through the board, and again we just solder on some of the pins. You don't want to get it too hot or it could damage the component. That's that done. So we've now got the pins on it there. Another thing to do is to heat shrink over the connections to make them a bit more secure so they don't short out on anything else. So we cut some small lumps of heat shrink sleeving and put them over the joints like that. Then we get a hairdryer and we heat them up. And we can see there that the sleeving has shrunk over the joints. So all the parts have arrived and have been, all the soldering's been done, like the wires on the switches and the things that aren't going to be wire wrapped. So the first thing I'm going to install into the box is the push buttons, because the wires are going to have to go under the battery box. So we put the switch in place and we screw the nut on, hopefully easier than the one I've just done and took ages. Threads are a bit rubbish on these. Then we can do that up with a spanner so we don't gouge anything. And we can get the nuts nicely lined up as well so it all looks neat and tidy. So there's two switches done. The next thing to do is to start to screw the circuit boards in place, which I'm doing before I put the battery box on so there's more room. And for this we need some nuts and bolts. We've got a good selection here and some spacers and things as well. Now I'm putting the temperature and pressure sensor on for the weather display up here. And I'm generally using these nylock nuts because they don't come undone when with the vibrations of riding the bike and doing wheelies and things. Unfortunately they're not easy to get for the very small sizes, the M2s and the M1.2. So generally what I do with these is use normal nuts and then put a blob of araldite on them to stop them coming undone. The Arduino is held in place by its USB connector at one end. And then at the other end we have one of these very small M1.2 screws with a small spacer underneath it. There's only one hole to secure it with that other end. So that's going to go in like that. Where there's a possibility of the nut shorting out anything on the circuit board, I'm putting a nylon washer underneath the nut. I have to make sure we have the right display for the box, if you remember, some of them were not straight on the circuit board. This one was particularly bad, so I had to adjust for that in the mounting holes, and not to over tighten them as well, because it can crack the glass on the front of the display. And then next I'm going to put in the socket for the wheel sensor that's used for measuring the distance. If you want to do that on it's an optional sensor you can put on to measure distances and so forth. That's going to go up through here, like that. Again, the nut for the wheel sensor will be aerodated when it's all complete, so it won't shake loose. So now I'm going to show you what wire wrapping is, and this is not used very much anymore. It was very popular in the 1960s. So you use this special solid wire, which is 28 standard wire gauge, and you use this special wire wrapping tool, and this in the middle is a wire cutter. So the depth of the tool is the length you have to strip off the wire for doing wire wrapping. So you just put it so it's just protruding out the hole, push the wire into the slot and then pull it, and it strips the wire. Then to make the wire wrapping connection, you push the wire up this slot at the side of the tool on the longer end, and then you put the hole in the middle of the end of the tool onto the post on the square post on the back of the component, like this, and then you just rotate the tool gently, and it wraps the wire around the post like that. And it should have a couple of insulated turns around the post before the uninsulated part. Let's take the strain, and that's how I'm going to connect all these components up. So this is all wire wrapping wire, because it makes it a lot easier, and it means if anything goes wrong it's much easier to change it than if all the connections have been soldered. If we wanted to undo that, so actually we haven't got the insulated turns on there, so I'm not very happy with that. You get the short end of the wire wrapping tool and you push that on and you rotate it in the opposite direction to what you did to make the joint up, and that loosens it, and then the wire just pulls off then. Right, so that's a better example. Now I've got the turn with the insulation on because I wasn't trying to video it while I was doing it. I bought this bargain reel of a wire wrapping wire on eBay because I was getting short of the stuff I had, and it was really cheap, but the problem is because it's about 8 different colours all on the same reel, it's going to get in a right mess. So what I'm starting off by wiring is all the display, the accelerometer, the weather sensor and the clock. There's like a communications bus between them, so I'm wiring those up first. So that's the data bus, the I2C bus, wired between the accelerometer, the display and the temperature sensor and the main Arduino. I haven't put the real-time clock in yet because it goes here and it sort of likely blocks access to things. And I've tried to use some sort of colour coding of blue for the data, red for power and green for ground. So the next thing to do is to connect up these switches and sensors to the Arduino. So that's now wired, the push buttons, and I've also put the LEDs in and the wheel sensor. And the next thing I'm going to do is put the battery box in. So I'm going to put the switch through the hole, pull the wires for the battery box through, which will eventually be screwed into place, but not at the moment. You see the wiring for the switches is all going to go underneath that. So that's everything wired now, apart from the real-time clock, which is going on these long spacers here. I've pre-wired the wires to that because they won't be accessible with the wire wrapping. So now all we have to do is put a battery in and see what happens. So we turn it on. And it's not very interesting, is it? No display, no lights, no nothing, except on the back on the main board we've got the main power light and a flashing red LED. Now the reason for this is we haven't loaded any software onto the, or firmware onto the Arduino yet. And they normally come programmed with a test sketch called Blink, which just flashes that onboard LED. So we've got to go over to the laptop and load the software on.